Okay, I think we are live right now. So sorry everybody for the delay. Our stream platform had a hiccup on the back end, which needs to be resolved. So I'm not even going to do the countdown clock because you guys have been waiting patiently for 22 minutes. Very excited about this live stream. We had momentarily thought maybe about rescheduling this, but this is too hot of a topic to reschedule. And we have this amazing dream team with us, including my awesome co-host here, Ashley, right above me. Hey, Ashley.
Hi.
You guys actually covered this very briefly last week on that awesome live stream. Um, and so we're going to dive in to NIM, and that's actually indeed the first news slide we have on the screen right now. How NVIDIA announced NIM agent blueprints to streamline generative AI development. So that's going to be the focus of today. We have lots of specialists from near and far joining us. We're going to give a nice overview, and then we're going to dive into use cases, and we're going to do a nice demo. So you're in for a big treat, and the wait was definitely worth it. Um, okay, before we get started, a couple other quick news announcements. Um, Obviously, we're going to be diving into this today. How these NIM microservices can be leveraged with OpenUSD and generative AI. Um, we also have the OpenUSD Day sessions are now available on demand. Our great producer Amelia is posting these links in the chat throughout the live stream. So if you miss something, just ask where we post it. But there you see it on the screen. We'll put it in the chat. Um, this is a great opportunity to get some free resources that really awesomely produced content from SeaGraph, which just wrapped up. We got to meet many of you there out there. It was great to see you. So now you can grab that content. If you couldn't make it, you can see it online on demand. Uh, at the same time, we also released our next ebook, and I think Ashley, you know some of these people. I know you know Matt Schwartz from
Oh
NJIT,
yeah, NJIT.
and I think you met Emily Bomer, possibly. She was on a live stream several months ago, but she was an intern over at BMW and showcasing some awesome workflows with OpenUSD. And so she is included in the latest OpenUSD All-Star book. You should definitely give this a read. It's a great way to learn about how other people are leveraging technology, lots of different cases, and it'll give you some inspiration, but also we just want to celebrate the great work these people are doing around the world with OpenUSD. So check out that All-Star book. I hope one day one of you people watching or more will be in the next edition of this book. So always feel free to touch base with us on Discord or on the forums if that's something you're interested in. Okay, so that's our announcements, and we are going to jump right into things. We have let's do a quick round of intros. Ashley, go ahead.
Hi, I'm Ashley Goldstein. I'm lead tech marketing engineer for Omniverse. So big part of my roles and responsibilities here is getting all of the developer documentation and demos and marketing information that we build here at NVIDIA for Omniverse out to the external developers. So if you saw the product configurator use case page with the reference architecture, that's a big part of the load we do at tech marketing.
Amazing. Yeah, and Ashley is also super helpful on the not only live streams but also on the Discord and forums. So sometimes you will see her helping people left and right, along with Richard Yartlett. So thank you for joining us, Ashley. Mr. Tyner, a veteran of the live stream series, has done many of these. But why don't you tell us a little about your background and what your role here is in NVIDIA?
All right, thanks, Edmar. Hey, everybody. Long time no see, possibly. Dave Tyner, and I do all kinds of things here at NVIDIA, and jumped on this NIM project a few months ago, and it's really exciting. Synthetic data generation, specifically AI, and sending prompts and having you do things that you want to do is really, really exciting, and I'm happy to show you a demo of that today a little later.
Amazing. Thank you for joining us. Bethan?
Hey everyone, I'm Beth Ann Noble, relatively new here at NVIDIA. I do product marketing for NVIDIA AI software, including NVIDIA NIM. I've been working as a product marketer in the enterprise AI space for some time, kind of back in enterprise AI 1.0, and then this new wave that's been powered by generative AI and the generative AI breakthrough. So it is super exciting to have come this far where we are with AI, this incredible technology, and it's great to be doing it here in NVIDIA. So great to be here, you guys.
Thank you for joining us. And we actually have an amazing video we're going to play in just a minute that Beth Ann helped produce that goes over some of the topic we're going to be talking about today. But you get to see some nice, nice eye candy there. Okay, followed up by we have my old friend Paul Callender. How you doing, Paul?
Hey, Edmar. Hey, everyone. My name is Paul Callender. I'm a workflow specialist on the Replicator team. The Replicator team builds an extension for creating synthetic data. My primary responsibilities are helping people to learn how to build SDG, and a lot of it involves kind of scripting, Python scripting, proceduralism, where all that interfaces with content, and generally figuring out how to make good SDG that performs well to train your AI.
Awesome. Thank you so much for coming. A bit of trivia. Paul and I used to work together on a couple of games back in the day, so we know each other way back. It's great to have him here. So we are very honored to have a very special guest also with us who was here recently. Alex, thank you for joining us once again. Alex, I don't know how you keep up with everything going on here, but you do such a good job about juggling so many of the crazy things we're always working on every day. Why don't you tell everybody about your role?
Yeah, thanks so much, Admar. Hi, everyone. So nice to meet you. I'm a product manager and definitely juggling with a lot of things. I work with our brilliant, amazing researchers and engineering to bring the latest and best generative AI technologies into product. And at the same time, I get to also, like me, work with talented workflow specialists like Dave and Paul to actually bring the product, the NIMs, into life, as you will see them. I don't want to spoil it, but you'll see something very exciting from them later on very soon. So I work on, of course, in the Omniverse organization and looking to productize generative AI technology. So looking forward to share a lot more with you.
Awesome. So we're gonna go around. Everyone here is gonna have a nice little section. We're gonna kick this off with that video I mentioned a few minutes ago that Beth Ann helped produce with members of the team, so that people have a kind of a nice overview understanding of what we're gonna be diving today regarding NIM. So here we go. We'll be back in just under 2 minutes. But check this out. This is great.
Generative AI is a game changer. Across every industry, more and more organizations are looking to roll out new applications that drive efficiencies, productivity, and revenue for their business. But to power generative AI in production, organizations need to consider security, latency and efficiency, flexibility, and how to manage infrastructure costs and scale. NVIDIA NIM delivers the features critical to easy, scalable deployment of generative AI models. NIM is a set of accelerated inference microservices that enables organizations to run AI models on NVIDIA GPUs anywhere, in the cloud, in the data center, and on workstations and PCs. Built on a cloud-native stack, you can deploy NIMs locally with a single command or orchestrate and autoscale with Kubernetes, unlocking the flexibility needed for modern AI workloads. NIM provides identity, metrics, and health check data for integration with enterprise management tools and infrastructure. Backed by powerful inference engines, including NVIDIA Triton Inference Server, TensorRT, and TensorRT LLM, NIM streamlines model deployment, ensuring seamless AI inferencing at scale. And with standard APIs, developers can build enterprise-grade AI applications with just a few lines of code. Part of NVIDIA AI Enterprise, NIM is the fastest way to achieve generative AI inference at scale, empowering organizations to innovate with the latest foundation models, deploy anywhere with security and control, streamline application development, accelerate inference, and cost-effectively scale out of the box. Get started today at ai.nvidia.com.
What an easy URL to remember, ai.nvidia.com. A great video. But then thank you so much for bringing that video to us. So if you're just joining us, we have a great panel today. We're going to be discussing generative AI models for OpenUSD leveraging NIM. So we've mentioned NIM lots of times. Let's talk about what NIM actually stands for so everybody can put this into context. And for that definition, I will pass it off over to Beth Ann.
Yeah, hey everyone, thanks for the watching the video. I think the soundtrack of that, the kind of the musical track in the back could have been a little bit more exciting, but thanks for watching that. So like the video said, NIM are portable, accelerated, customizable inferencing microservices for every domain across generative AI. So not just LLMs and reasoning foundation models, but visual design, simulation, biology, and more. So this is not official messaging, but I kind of think of them as sort of portable generative AI supercomputers for every domain.
I love that.
Um,
It should be official messaging. I'll speak to the marketing team
well,
about
we can
that.
work on that. Let me know how that resonates.
That's great. Okay, so so now okay, so we're going to kind of cover how it actually can transform OpenUSD workflows, and we have several people here going to be talking about it. But Beth Ann, what else can you share with us about NIM as far as an overview?
Yeah, absolutely. So there's a lot of different value points that we're trying to bring together with NVIDIA NIM. I kind of look at NIM as at the intersection of four mega trends. So first you have generative AI, then you have accelerated computing, coming from NVIDIA accelerated infrastructure, also composable microservices. So building with composable, API accessible cloud native microservices. And then finally, kind of thinking about more in the IT and deployment side of the house. I saw somebody's question in the chat. Why is the Kubernetes aspect important? Because the other kind of fourth megatrend where we're kind of meeting with NIM is hybrid multi-cloud cloud native deployment. So we find at NVIDIA, our partners, customers, our own customers do want to be able to take advantage of the manageability and the scalability of things like Kubernetes, and they want to be able to deploy generative AI at scale on whatever infrastructure they want and across different infrastructure. So there's really a lot of value here. I think one of the key points is also just delivering these inferencing microservices with NVIDIA's special high performance inferencing engines built in, and then exposing that, when you deploy an NIM, you deploy an API, and any developer, who's accustomed to connecting to third-party hosted APIs, for example, we saw that in the video, can just immediately connect to a NIM microservice, and it's all the same to them. So you're getting opening up access to more and more developers everywhere. You're giving IT and the people who administer and manage the software standards and reliability and scalability. And because this is all running on NVIDIA GPUs, you're getting a lot of additional performance throughput. I think there's been some news today coming out of ML Commons, the ML Perf 4 benchmark. NVIDIA had some very industry-leading results there. So what that means is that you're going to be able to do a lot more inference on a lot less infrastructure footprint and really lower that TCO to get more and more tokens for less cost.
That's amazing. It definitely seems like the focus now is increased accessibility and just basically taking OpenUSD a step further for enabling that access. And a few minutes later on stream, we're actually going to show a nice example that Dave and Paul are going to show off, and how you can use this technology for creating digital twins with generative AI. So stay tuned for that. But Beth Ann, it's not like this is obviously with this increased accessibility. One of the things we're most excited about is the power that it's going to add to people working in robotics, right?
Absolutely. So, I think we've all seen that the big generative AI wave was really kicked off by GPT, like a large language model. But generative AI, just like language, it can learn and understand anything. So not just language data, but visual data, physical data that represents like physics and science and biology. So NVIDIA, having specialized for years now in truly vertically integrated accelerating computing software, is now able to deliver that software that we've been building for heavy industries, for automotive, for creative industries in the NIM form factor. So that means all of the setup that one might have to do when they're working with SDKs and hands-on kind of DIY with inferencing software is that they have to build and work on implementing the APIs and all of the code that processes input and output to the model. They need to do that themselves. But what we're doing here is giving you a ready-made standard package that just surfaces the generative AI for that domain through an API that developers are used to working with. So that's opening up generative AI to a lot of different industries, and that's what we're going to see here when we get more into the OpenUSD NIM.
That's awesome. Thank you so much. It's really helpful. Definitely keep the questions and comments coming in the chat. We'll keep an eye on them and try to answer as many as we can as we go along. Um, Let me see. So, and Alex, so you have actually you're going to go into a little bit more about how this incorporates into your workflows for generative AI, specifically regarding copilots. How I think you have something you want to share.
Yeah, I do. I actually have some slides. I think for all the audience here, I think NIM is the keywords, and I want everyone to register that. And actually, we'll make it very easy to try. What I'm gonna show it very quick throughout my presentation. You can literally start using it like today. Okay, so I'm going to share my slide. So what I'm going to talk to you about is how we bring generative AI to OpenUSD workflow with NVIDIA NIMs. And to demonstrate that, there will be two workflows that we'll be talking about that's hopefully relatable to what you're working on. The number one is content generation. How do we produce massive amount of high quality content with generative AI and Omniverse and the NIMs? And then Paul and Dave was gonna also going through the synthetic data generation for digital twin workflows, and I'm gonna give you a quick high-level overview on what that is about. These are two workflow applications that we're looking at Omniverse bringing generative AI to OpenUSD workflows. All right. So with that said, I think without further ado, we all understand that generative AI, we're all thinking about how we can put into our production workflows. And 2020, the end of 2022, with ChatGPT come through our lives. And I really would see massive explosions of a lot of POCs with enterprises, with hub developers, and across the board, right? And I think it's easy to get them started. It's easy to build demos, to build POCs, but really, how do you take it to a production environment to make sure the application runs smoothly, the application runs consistently and robustly across the board for any traffic that you are going to work through. So that is the problem that we're solving for enterprises to make sure that we can simplify that deployment, to make sure that we can handle multiple models that working in that complex pipeline and at scale, and eventually to serve the business generation for the enterprises that we're working with, and then for the applications that adding value to their users. So like you saw in the video that Bethany has shown, really named that very simple three-letter acronym that is a beautiful, I would say, aggregation of a lot of the engineering work that all NVIDIA teams have bring on to bring this generative AI to deployment easy for you. Not only it comes with OpenAI compatible APIs, which makes your integration of those technology to application and workflow super easy with just one line of API call, but also, in order to get the best and most acceleration through across all your GPU nodes or instances, be it in cloud or on-prem, right? We have the whole stack that's accelerated on a GPU, so you can get the most bang out the buck of all your hardware that you have invested, from inference deployment acceleration to model level acceleration to make it work cloud natively, and on top of that, the security that every enterprise care a lot about. So that's all the greatness and good value that's condensed in this complex stack, and we simplified to a single line of APIs, and we call this NIM to make hopefully it's easy for people to understand what it is. So we have NIMs actually for all the verticals. We have NIMs for healthcare. We have NIMs for gaming, etc. We have NIMs for typical enterprise applications. We also have NIMs generative AI for OpenUSD. So what we have launched, and it's already today in the public, is one is called USD Code, and then the other is called USD Search, and another is to validate USD. We call this USD Validate. And I'll walk you through what they are exactly about in the next slide. We're targeting at two main industries. Number one is robotics, right? So we want to make sure that robotics can focus on training robots and then using generative AI to accelerate the development of robotic foundation models. The other vertical that we're looking at to apply those NIM to and through workflows is the industrial design and engineering vertical. So how we can bring the NIMs into the OpenUSD workflows in, for example, the digital twin building. Essentially, these two workflows are actually interconnected. You can test and deploy and validate the robotic behavior within the industrial digital twin, and then take it to real life and at scale. Now, I'm sure everyone, if you're listening online right now, you're via laptop, I'm gonna be totally fine if you open with your browser and typing these, URL there. If you search USD Code, NVIDIA API Catalog, you should be able to find them online. USD Code is a state-of-the-art large language model that we have optimized and we have custom and tuned, and specifically to understand OpenUSD. So you can input any text prompts, be either asking a knowledge question about OpenUSD or you want to generate, OpenUSD Python code snippet, you'll be able to provide you that. And then we also developed actually the Omniverse sample kit extensions. So you're working your workflows within Omniverse, and then how do you bring that into your workflow? So we have everything documented. Highly recommend that you get it tried. All those links are live. USD Search. Everyone probably work with all the 3D asset is that managing those 3D assets is so painful with manual tagging and annotation. What if that one day, you could just simply search for what you want by its name and no tagging at all, and then the relevant asset is going to come around. And this is happening literally right now with USD Search. So we can search by any text or image, and then we can scroll across your asset management database and then find the asset that you want and then rank by similarity scores. And this is again also live. We demonstrate that with our what we call industrial sim ready assets. So you'll see a lot of the assets in the realm of warehouses. That's what we show as example, but you can actually take that and then deploy that with your own database as well. The last but not least is USD Validate. While you're working through that, whether we wonder whether this is USD compliant, you can upload your file and then USD Validate will validate everything with you, make sure that it's USD compliant. So all of these three are available today on NVIDIA API Catalog. It is I'm always so proud of the team because whenever I go on a talks or panels, I can just ask everyone to take out their phones and then type in, build.nvidia.com. And that's where, all the goodness of NVIDIA technology will be presented to you. And literally you can try it on your phone, on your laptop, anywhere on your web browser. And then you can generate the API key very easily. And then we provide ample credits for you to do testing in your own applications. And then you can see how you like the capability. So we try to make we try to bring the technology as easily and closely to application so that it's easy for you to test and evaluate, and then make a decision on whether you want to invest further to buy a license from us. So definitely don't hesitate and try them out and let us know what you think about it. Now let's look into a few applications. The number one is looking to content creation. So we're all familiar with Midjourney, Stable Diffusion, and to start as a starter, a lot of folks will generate a background and then replace foreground. However, the downside of that is it is really hard to get to the quality, the controllability of the content that the artist is looking for exactly, right? So we're here talking about extremely high quality production content that an advertising agency wants to put out there for the users and for their brands that they're supporting. Now, what we're looking at is that how do we leverage Omniverse, where you can have the high fidelity render with all the correct lighting and the shadow and the variety of massive backgrounds of high quality you can generate. So that is where we call this controllable generative AI, and also for the artists to actually accelerate their workflows. For one example, you want to renovate your kitchen, and it's easy to get a variety of amazing images from diffusion models. Now, but you have a specific way of arranging your furniture. Let's say all the gray box things are laying out here for the spatial configuration of your kitchen furnitures, and you want exactly that. Now, with the controllable Gen AI, you can bring the Stable Diffusion or NVIDIA Edify, which is we trained on a lot of the with the Getty dataset, and it's all fully clean data and licensable data, to actually bring that exact spatial configuration and with the creation and generation from the diffusion models all together. Now you can see it's exactly the layout that you would like for your kitchen with exactly the furniture that you would like to see. But with the different backgrounds that's generated from the Edify Getty model or diffusion models of your choices. Right, so we work with actually one of the leading industrial partners on the advertising in space called WPP. And what we have done so far, for example, this workflow that they wanted to change the background of this plate of amazing, delicious fried chicken, which I really want right now, and the Coca-Cola bottle in the foreground. And they're collaborating and then partnering with Coca-Cola company. So they take this base thing that you can see on the left, and then the asset, main asset, the focal asset is the Coca-Cola bottle. And now they can overlay that. They generated this background and overlay that with the bottle, but with see all the lighting and the reflection that come through nicely with from the bottle and all of that. That is what we say the quality and controllability that we design to bring into the workflow and add value to the artist today. There's a lot of, if you kind of deep dive into, okay, what are the technologies that goes in to actually bring this to life? You can see that on the right-hand side, there are various NIMs that you can see this icon. Edify 3D is text to 3D asset generation, so we can generate the asset if you don't have them. And then we also, with the background, we use, Edify image, which, the equivalent in the community will be displayed with Diffusion to generate the background image. And then we use USD Code and USD Search to help actually author the thing and modify the thing, and then search for existing asset if you have it in your database to bring it all. So you can see it is almost like AI collaborating with the artist to bring out the mass scale, high quality content. Another use case, if you think about content creation, but more for the industrial environment, would be for digital twins and training robots. We need a lot of synthetic data. Dave and Paul will walk you through a few demos on applications. So essentially, we again put the names in the work, right? So we have the USD code to help author different and change different lighting conditions. We can bring different background and then also assets that you don't have with Edify 3D or 360. And then the USD code can use again to modify your, the scene environment that currently that's in Omniverse. And then you can carry out the domain randomization with the Edify image and then also the domain randomizer. And eventually you can send your models to be trained in something we call either in PyTorch, if you will, or something we simplified we call TOL for computer vision specific purposes. So we have actually this workflow guide also authored and right now live as well on NVIDIA Docs. So I'm more than welcome to try it out, and we'll share the links with you as well. So you can see on the left, this is spacing, and now we can randomize the lighting and then different assets on top of that. Essentially, once you create base content, you can randomize the environment, and then you can actually add on different assets as well as part of the randomization. You can augment the scene from that. So with that, I think I'll hand it over to Dave first, and then to demonstrate the workflows, and then Paul will talk about the domain randomization with SDG. Just totally try it out on API Catalog after you see the demo and build your own things and share with us. So with that, I'll hand over to Dave first.
Very cool. That was fantastic, Beth Ann and Alex. Thank you so much for those great overviews, for giving everybody context. And now I can share Dave's screen, who's got something prepared. Is that Alberto Arenas?
That's Alberto Arenas.
What a great guy. I'm Omniverse ambassador from the community. Really fantastic developer. Over at WPP now, I believe.
Yeah. Great guy, absolute titan of industry.
He is, indeed.
All right.
Okay, cool. Well, you guys can take it away. And just a reminder for the audience, feel free to keep posting any questions or comments in the chat. We're trying to keep up with all the links. And any on the panel, feel free to interject at different points if you have anything to add to whatever anybody's saying. Okay.
Everything leaves me speechless, so I can't ever interject because I have nothing to say. It's just also great.
I've never heard you so quiet in a live stream before.
Well, I'm also at headquarters, and as you can see, my face is very white, and that's not because I am lacking sun. It's because of all of the amazing windows that this building has, and I'm just getting all of the sun. So I'm also kind of blinded.
Well, we're both at headquarters. We had to switch rooms so the echo wouldn't be bad. But yes,
I'm in the better room.
Yes, she is. But I have Clammy up there, so.
I know. I'm so jealous. I have to come say hi to Clammy later.
Okay, so here we go.
I had to share again, so.
Okay, here you go. I see.
Yeah, there we go. Perfect.
Okay, take it away.
All right, awesome. So thank you, Alex. Thank you, Edmar. Thank you, Ashley. Thank you, Beth Ann and Paul. So we're going to be going through our Generative AI for Digital Twins guide that we published, I don't know, roughly like a month ago. And sorry, camera's over here, my screen's over here, so I'm going to be over here most of the time. And basically, this is like takes you through, first of all, everything that I'm going to be demonstrating is in this guide. So if you get hung up or whatever, just reference this recording and you'll see the guide. Also, shout out Pekaveris. Hey man, how's it going? Basically, this guide takes you through soup to nuts, how you pull down the Kit app template, how you create a Kit app template, how you build it, how you configure your extensions and settings for those extensions, and then actually launch the application. Also very important, getting the API keys so that you can actually run this. None of this will work without the API keys. All of this is free. Don't worry. Just follow the guide. And all of that said, I'm just going to jump into the use cases here. So the first one is we're going to be generating a, oh, sorry, I'm skipping around. Another thing that's included in the guide is we have this awesome USD code running inside of VS Code via the Continue extension. So if you're developing an extension or an application and you don't want to be futzing around with the Kit script editor, you can run USD code right inside of your development environment. And it's not just for producing code, which it does really well, but you can ask it about USD, like, what the heck is liver peas? And it's going to run and it's going to tell you what liver peas is. You ask it, hey, what's the difference between a payload and a reference? It'll tell you what it is, how it's used, the functionality, and things like that. So yeah, it's super, super cool. And then
I love liver peas.
Liver peas, yes, give me some liver peas. Or you could just say, hey man, create a cube, and it'll give you the code to do that. So super cool stuff. But this is running in VS Code. I'm going to be spending most of my time here inside of Kit because we have the same thing running in Kit. So I've already obviously configured the application. I have the AI agent running. It's got the 3 nodes here: USD Code, USD Search, and USD Code Interactive. So we're going to be going through the use cases, kind of basic use cases, but hopefully it's enough to get your imaginations racing and unleash yourselves upon it because it's really, really exciting and the first step into this brave new world. So let's get started. So the first thing I'm going to do, I'm in this warehouse, which of course is also provided. I already have lights set up in here, but I'm going to turn those off because what I want to do is I want to create a light grid in the stage. So let's go down and I'm just going to grab the prompt. And basically it says, hey, create me a 6x5 light grid with some light properties, which feel free to change those around, and then nest that under an X form in the stage called root lights. So let's run that. It's also important to note, I guess, that it's non-deterministic. So depending on the seed that it's on and the prompt that you give it, it's possible you're going to get different results. Now, what you saw is it runs through the code, it error checks the code, and if there's an error, it'll regenerate and check it again. And if there's no error, then that's awesome. So I'm going to go ahead, go up to developer, script editor, just dock that right over there and move that up like that. And then this handy dandy copy button, I'm going to paste that into my script editor, but I don't want to run it yet because what I need to do is USD Code will always create your stage in memory and not deal with the stage you have open. So you want to replace the USD stage created memory with, hey, work in my actual stage here. And then this down here at the bottom is going to print out the USDA file into the console. So depending on your stage size, you might not want that. I definitely don't, because this has like 4,000 references and it'll take a while and it'll kill performance. But anyway, I'm just going to go ahead and run this. Hey, and look at that, nothing changed, but it did. It created my lights X form, and underneath my lights X form, I have all my rec lights. Now I could take that and I can say, all right, move into the position that I want, but I don't want that. I want it to do everything so that I don't have to press any buttons. So to do that, I'm going to tell it in this second prompt here to modify the code. I don't know if I put these question marks in here, something with the web page. Modify the code, and I want you to move that XForm into its proper location. So I'm going to run that again. It's going to go through and generate new code on top of my existing code, right? It's just going to insert the part that I asked it to do, which is awesome. And I'm just going to grab that part like that. Actually, I probably just need, well, I'll just grab all of it. And I'm just going to put it right in there like that. And let's run it. Voila. All right. So you can see, and then you can continue, like I've said, okay, now make all the lights random colors and make them different sizes and whatever. I mean, it's just like, just go crazy with it. All right, so now what I want to do is make sure Alberto's in the picture. I'm going to use a new agent called USD Search. And USD Search is going to search all the available assets that we provide, high quality assets. And all I have to do is prompt it for the assets that I want. So I could just say, hey, I want some racks. And it'll return, the racks that it has. Or I want to say I want racks and pallets. And it'll give me racks and pallets, and I can keep going. But whatever. But the important part is that the assets that it returns, the results that it returns, you can just drag and drop them into your stage like yay, which is super cool and super handy. And again, play with that all you like. So now, a really exciting component of this, and another node, is USD Code Interactive. Now, USD Code Interactive is aware of your stage. It understands your stage structure and where things are. So what I want to do is I want to tell it to, I want to duplicate this guy. So I'm going to tell it to duplicate prim that 4 times and space then 2 units on the x-axis. And it's going to just do it for me so that I don't have to touch anything. So that's awesome. Now I'll select those, group them, and then I can do whatever I want and place them. And obviously I can use more prompts to do things, but you get the idea. It's super cool. Like I've done in this stage that you'll see when I first got it, sort of ad-libbing here, but sometimes you get the problem where you select a reference and then it selects the first child of the reference. And it's really annoying because you start moving it and you don't realize you select the child reference, and then it's all off of the pivot and it's terrible. But I told it, I said, hey, I want you to go through and I want you to set the right component type of the prim to be a certain type, so that when I select it, I'm selecting the highest level in the reference and I'm just moving the reference and not the child. And it totally did it, and it was awesome. So there's a whole bunch of stuff you can do with this. It's super cool. So, all right, so boom, we're going to get rid of that. We're going to go into that. So I already had some light set up, but I just wanted to show you the light grid demo. So the next thing we're going to do, and I'm kind of jumping around in the guide here. I'm going 1, and that last one was 3. And then this one is going to be use case 2, which is using USD code to in Replicator. And what I want to do is I want to create some domain randomization on the stage so that we can train the robot what it looks like with the lights on and the lights off. And so to do that, there's 2 examples in the Replicator use case, and I'm going to go to the second one because it's cool. First one's cool. Second one is a little more visually cool. So now in Replicator, when you use Replicator, you have to use this shell script that calls the all the Replicator libraries that you need. And so what we're interested mostly here is, all right, we want this toggle light function. And so I'm going to jump back here. I'm going to grab the prompt that says basically in the open stage, I want you to create a function called toggle light that toggles the visibility of my lights defined here, root warehouse lights, and then those lights right there. So let's go ahead and run it. And what you see is it'll probably, what I've seen is it doesn't get it right on the first couple, and then it takes, I don't know, 2 or 3 to get it right, but it'll get it.
So wild.
It's so handy, I'm telling you. Rather than pasting that in, pressing the button, tracing the error, finding out what it means, it's just like, hey, NIM, do it. And if it does error, all you do is you paste the error in the chat, and it'll go through and say, oh, sorry, I made an error, and here's the fix for it.
Yeah, all of these are publicly available, meaning that you can literally try it today. It's no longer sci-fi anymore. You can try it and use it in your workflows.
That is awesome. And this guide is fantastic. We've been posting the links for all this stuff in the chat, even sometimes double posting. So sorry about that. That's me and Amelia fighting over the this is a chat. But yeah, feel free to just let us know if we missed something, and we'll add all these links to the description afterwards.
All right, sweet. So I got my toggle light function, and all I'm really interested in is the function and all the extra stuff. So I pasted that in. And one thing that I need to fix in the guide here is you're going to have to go in and send the stage variable into the function, because that's what it's expecting. So you'll have to type in stage until I fix the documentation and the code snippet. So anyway, let's all just kind of cross our fingers, and not cross our fingers because this is going to work. All right, let's go. All right, so you see the lights flicker on and off, on and off, on and off. And what's happened was we have written to the default directory, which is C username omni.replicator out, and it's taken a normals render, an RGB render, and a segmentation render, so that you can take all of that. So I'll just, so there's off, on, off, on, off, on. So if you're trying to sneak into this warehouse and the lights are off and you think you got it, the robot's going to know. So don't do that. So anyway, and this is wonderful because this you can use these downstream to train the robot. You can also use them for the next demo, what Paul Callender is going to do, which is going to take these outputs and then feed them into a stable diffusion ComfyUI graph to generate some 2D renders that you can do domain randomization that way. So that's it for my portion. And Paul, it's all you.
That was great,
Thanks,
Dave.
And then I wonder if Paul, after your session, maybe we have time, we can walk you through all on the API catalog, and then how do you get to hands-on to set up all the kit extensions that Dave is using, and then API catalog, etc. So maybe after Paul will steal for maybe 2 minutes.
Yeah, and I guess I just want to say that everything that you see here, publicly available, free to try. So don't worry about having to pay anything. You can try this all right now.
That's great.
Well, after the live stream, of course.
Yeah, don't start right there. Wait 15 minutes.
Yes.
Okay, Paul. Paul, you're sharing?
Yep, I'm going to share my screen.
Okay, great. While Paul's doing that, we definitely have some good questions. Hundreds of people watching right now, so welcome to the live stream, everybody. We're going to try to circle back to some of these questions after Paul's part here. And I know because we went over, Bethan or Alex or anybody, if you guys are hard stop, just feel free to wave goodbye if you need to go. And want to thank you in advance for all your great context here. I see Paul has joined the screen, so here we go.
All right. So this is use case number 4 in the series. Basically, it is using Stable Diffusion and ComfyUI to augment synthetic data sets that we had just previously created in the prior use case. So to kind of give a high level as to why you'd want to do this, I'm a technical artist myself, in addition to a workflow specialist, or maybe it's the same thing. And it's really difficult to create synthetic data. You want to create a ton of good-looking stuff that matches real life, and you have to make it at scale. Traditionally, that involves like a lot of proceduralism. You know, we're talking about using Houdini or kind of game engines or Omniverse in this case. And you just need a lot of expertise, and it just takes a long time, even for people who have that expertise, to build this stuff. And obviously, with generative AI, there's an enormous potential to be able to flesh in a lot of the details that one would want traditionally. But one of the key distinctions, I think, here is that this is all about a level of control. So for synthetic data sets, it is imperative that the end results are not, I have this phrase, not obviously wrong. You don't want something kind of punching through a wall or doing something that might be kind of detected as something that should exist in real life. So a lot of this is around swapping out very specific parts of an image while retaining the kind of global structure of what you've created in the scene from your synthetic data set. So to give people a little more context here, this image here is what you would typically have with a synthetic data set. You could also have things like bounding boxes, 3D bounding boxes, or instance segmentation or whatever. But for the purposes of this, we have our RGB here. We have our segmentation maps. This is a semantic one. So the green is the forklift, the pink is the background, the floor here. We take in the normals and a depth as well. And I'm not really going to go through a ton of this. This is kind of mostly just setup stuff, but please feel free to take a look at all the nitty gritty. And I'm just going to jump straight into the graph. Alrighty. I apologize that this may look like spaghetti to everyone, but this is ComfyUI. So what we're doing is we're using ComfyUI and SDXL to augment the images that we just talked about from our synthetic data set. From a high level here, you can see that we are bringing in our images here from a synthetic data set. This is just one frame, but as I mentioned before, we have our segmentation, depth, normals, and RGB. And this graph is ingesting these. It's making masks from the segmentation, and we're controlling the generation using a series of regional prompts here. So the most important part of this in terms of changing things is in these prompt sections here. So you can see that I've broken this out into, this might actually be a bit difficult for people to read, but we have our forklift here. We have our background prompt. We have our pallets that are on the forklift itself. And there's a garbage container in the background that we kind of randomize. So a lot of this kind of devil in the details. What we're doing in this section here is breaking things out by mask, and then we're combining the masks along with control nets. I will explain control nets in a second here, but these nodes here are kind of building up these regions where we want to kind of order the prompts, restrict what's getting generated, and what this does is it largely controls the structure of the scene that we want to maintain its structure with. And this is where the control nets come in. So if we jump over to the control nets, these guys, there's 2 of them here in this case. We are using a Canny. I actually think we might be inputting HED, but Canny is the one that was working quite nicely for this example. And we are also using depth. So the depth here controls, if we move over to our image here, here is our original. And then this is one of the generations that I just did before the presentation here. And what we're using the control nets for is to make sure that the generation fits the bounds, and the depth controls the form. So you can see here, we actually generated some of these props here. These boxes here were generated with Edify 3D, and this garbage container was also an Edify 3D model. And the purpose of these is, in this case, to generate the 3D depth map and also the outlines from the segmentation. And then we want to in-paint them, the foreground objects, to give them a much more photoreal look. We've done the same with the forklift here. So this kind of refer to this as in-painting in this case for the forklift. And then the background here has been changed from a kind of it's like a dark blue painted concrete. And then we just swapped it out to a green linoleum in this case. I think it might have chosen the green by itself. I left the color out on purpose.
It looks pretty close to NVIDIA green. I don't know.
I was about to say, suspicious.
It's true.
Uh-huh.
Yep.
You sure that's not my garbage can from my Learn With Me stream I did? Just kidding. I've never model anything as nice as that.
So one of the interesting things about the Edify 3D here is that these are kind of prototype assets that are generated very quickly for the purposes of just getting variety into the scene. And one of the key benefits for this is being able to use those assets as guides for generating things that are like those, but much more varied every time, every permutation you go through for each of these. So I'm going to give this a whirl and change something, and then we're going to see what the... So we've got a dirty dark red counterbalance forklift. Let's change this to a shiny, clean orange counterbalance forklift. And let's change the linoleum
Can we do
floor.
a glitter floor?
Swimming pool.
Glitter? I'm afraid to try glitter.
Glitter.
We can try it.
Glitter pool.
Glitter covered concrete floor. I have no idea what's going to happen here. This is going to be interesting. And a garbage container. Let's try metal. All right. So let's cue that prompt. All right. So while I wait
for the glitter,
this, I'm gonna pull up some other examples that I generated just before. Okay. So these are a little bit lower resolution, just because I wanted to save some time. But some of the really interesting things about this is that it gives non-obvious visual details that I just wouldn't expect, right? These reflections are pretty, at least to me, they were very non-obvious that it would have the capacity to generate this. It's also kind of inferred that there's a window above this wall here, which I think is super interesting. And it's maintained that on the kind of wet surface here in addition to the dry surface. One of the interesting things that I'll mention a little bit later is that there's a bit of interplay between the control nets. So the control nets control things, and if you control them too much, it kind of clamps down on the creativity that's going to bring. But if you reduce the constraints of the control nets, it's going to change kind of the depth of the floor potentially here. So this is one area that kind of demonstrates that if you relax the constraints of the depth in this image, then it's going to generate things that are plausible, but maybe a little Escherian here. Here's another one. So this is a good example here. This is well, it's a little bit weird because I've specifically prompted kind of snow in here just to push things a little bit, but it's been generating very large 3D objects in the scene here on the floor because these pixels have relaxed the constraint a lot with that depth. So this follows more of the canny line bounds. Oh, and this is funny too. This light here, in my prompt for these palettes here, I put in light color wooden palettes. And I found later on that it was sometimes putting a light alongside them. So you kind of have to be very careful with your prompt crafting. Yep. It's
look
the same
how
thing
fat
here.
that trash can was. Did you see that? It was so wide in the last one.
Yeah.
It's so big.
Chunky. Yeah.
Ashley's really obsessed about trash cans today.
I've
had to model some.
I can't stop thinking about the one I never finished in Blender. That was the problem. It haunts me every day. Zia doesn't let me forget about it.
Wow.
These are
Okay.
great. Oh, wow.
Kind of
Hey.
got
This
the
is
Is this my
glitter.
glitter?
Yes,
Now
that
you're
is your
talking.
glitter.
Oh no.
Well,
I'm
I
so
don't know. It
sorry.
looks like some glitter on the right.
We should have did
This
the
is totally
pool.
glittery. Yeah.
It's a warehouse party.
It's like neon. It's not glitter. It's
I
like a
guess it
rave.
associates. I guess it associates. Yes, exactly. It associates the neon with the glitter. Let's let's go on with another one. Let's see what the next one looks
Raven in
like.
the warehouse.
Yeah.
Here's some more mundane ones. So this one, kind of adding a little bit more details to the forklift here. One thing to note is, obviously, these are not perfect. This is largely down to resolution at this point. So once you start cranking up the resolution higher than kind of 1080p, these kind of warbly generations, the control nets will be able to guide those much more stringently. Here's another one. This is one I just stuck some grass in the bottom here. It's kind of like a very, very low cut lawn grass. It's like a bowling green.
That's like every dad's dream right there.
Cricket. And here's another one with linoleum.
Ugh, can you imagine working in a warehouse with that kind of floor though?
My
You
eyes.
throw up every day.
All right, let's
It's
see what
so
we get
great,
for the.
though. So powerful.
Still
That's
waiting
like
on the glitter.
this is like a Miami warehouse.
I'll put in a somber one in a second. But
That
overall,
little like rectangle that it made in the middle there, what is that? Why'd it do that? Is that like a reflection it's trying to do?
I've seen it generate patches on the floor.
Oh.
So I guess it's kind of picking up, especially when you put in like linoleum, it'll kind of put like tiles sometimes, like small tiles patched in. Oh wow,
It's
that's much
highlighting
better.
that part of the shelving is rave material.
How's this for glitter?
Oh, that's nice. This is great.
That's classy.
I want that in my house.
Okay, I'll take one more prompt and then I think we'll pass this off. Suggestions?
I'm not allowed to suggest anymore.
I remember Dave
Swimming
said
pool.
swimming pool. Yeah.
Swimming pool?
Yeah.
How about we do flooded? Swimming
Okay.
pool might be kind
Swamp.
of conflict a bit with the depth.
We should do
Flooded,
swamp.
I was
swampy,
suggesting putting people in there.
concrete,
Oh,
floor.
they'll have too many fingers.
So in this bit, so this is an interesting point. The ComfyUI workflows are built to give a certain effect. And what's built here is really around modifying regions with a specific prompt. And with people, hit the
Would
cute
they
prompt
just be
here.
like, it would just be people's faces as the floor?
It would try to put people in, but it doesn't have the cues that you probably want with the control net, such as the open pose or the segmentations or the depth to really control and kind of clamp down where the people should be, how they should be posed. It's just going to kind of hallucinate people into the area that you give the prompt. But because of the
then we're
depth,
really at a rave, right? Hallucinating people. We're really, it fits.
I think the challenge there is that the depth of the control net is going to say, I'm a flat surface, but it's going to try and generate people on top of that. And I find that a lot of times the generations that don't work is where you're trying to fit a prompt to a region where you're also trying to control it for something that is not matching the prompt. So ideally, you want those two to converge to get the best generations. Waiting on this. For the record, these are not built for speed. These are built for the workflows that I like the results from. There are different models, turbo and all sorts of other things that you can use to generate much faster generations. The reason why we're kind of going with SDXL is because it's the most mature model in terms of having the supporting nodes that do different things. So another type of nodes that are not used here is an IP adapter. There's a whole menagerie of different nodes that support these types of workflows, and a lot of them are pretty critical for getting the high degree of control that one would want to get consistent, reliable results for synthetic data. If you just want to generate the stuff, and you don't mind a couple of bad generations, you can kind of flick through them. That's fine, but the scope of this sort of work is to get reliably good results, because you're not going to sit there for 10,000 images for your data set and take out the bad ones. A little bit of prompt bleed between these two,
That's
but
pretty
it's
cool.
definitely swampy. Yeah, so we're just kind of having fun here.
Wild tool.
If you want to stick to the more mundane warehouse prompts, you're probably going to get more reliable results, but it's always fun to see what it comes up with.
Looks like the palette is on fire.
The palette here is getting a little bit of prompt bleed between the orange of the forklift here. The models can sometimes have difficulty knowing which part of the sentence applies to which prompted region. So it's known as prompt bleed, but
and the garbage is floating.
Garbage is floating because we've asked it to put a swamp on this area and adhere to the depth, but it doesn't know how to make this. Because we've told it to put this garbage container here, so it has no choice. We've asked it to do two things, and it's complied. All right.
This is great.
Any other
Very
questions?
cool. We have a bunch of questions, and I'm looking at the clock, and I want to be very respectful of everybody's time, including the audience. So what I
Hey,
think.
Edmar,
Yes, go ahead, Dave.
can I interrupt and
Yes.
could you share my screen real quick? I just wanted
Oh
to show
yeah,
off
of
that
course. Here we go.
this is what I did using a similar graph as Paul's, but basically just a depth map, edge map, and an ID map, and then I just prompted what I wanted going on for
That's
each.
This
of
is
the-
amazing.
Yeah,
There's a point where the monster's kind of throwing up. Maybe he just left that warehouse with the green floor.
yeah, but I mean, you can see like there's interaction between his feet and the water. I mean, it's. I mean, obviously it's basic, and there's a whole bunch of stuff that needs to be fixed, but just
that is so cool.
Where this could go.
This is the mind of Tyner,
Blows
for
the
sure.
mind. Yeah, and all this created in Omniverse, except for this stable diffusion, of course.
That's crazy.
Anyway.
That's amazing.
That's amazing. What a great. Okay, let's keep this on screen for a few minutes. What we're going to do now, I'm going to suggest we do a little speed round of questions. Our producer Amelia has done a great job at highlighting some of the questions in the past hour or so. What we'll do is I'll go through some of them. If one of these questions is not a good fit to talk right now, either because we don't have information or just we don't have an answer, what we'll do is we'll say post it on the Discord channel, live stream channel. On our Discord server, we have a live stream channel. Post a question there. If this is your question, we're going to skip, and we'll get back to it there on the Discord server. Otherwise, anyone on the panel, feel free to take any one of these. We'll start with Ordinary Alan. Here we go. Who actually is an Omniverse ambassador. Sorry, Beth Ann, for cutting your face off for a second. Will NIMS microservices have a recommended way to interact with USD scene files? Need to be shared with other NIMS. Who can take this one? Or if we don't have a good answer for this one yet, we can follow up with Ordinary Alan on the live stream channel.
Well, there's the USD interactive node inside of Kit that does interact with your stage. I think that's the question.
Yeah, I agree. I think we actually. How about can I steal? Sorry, I'm not gonna steal the screen real quick for 1 minute, and here I can actually walk you through what actually Dave just said. Sorry, the monster's gonna go away just for a little. I'll be back. Promise. Okay, I'm gonna share this. Let me know if you can see it.
Okay, here we go. I see it.
All right, good. So this is API Catalog. You can go on build.nvidia.com. You will see every category under visual design to simulation. So all the OpenUSD workflow names that will under a simulation. So if you click on this, this is the USD code that Dave has been using in the Omniverse Kit extension environment. And then, so if you go to projects, there's this tribe project will link you to our documentation here. And then under this page, you can actually find USD Code NIM in Omniverse-based kit application. So if you scroll down, these are all the setup. This is the window, the main window that Dave has brought up early on. And there is one node called USD Interactive. And then this is where you can actually do a lot of the scene modification as that Dave was showing you early on. For example, change to different lighting, right? So this is where you can search the database, and then like in this one, we have USD Search. You can search out your database, finding an asset you would like, you drop in this, all right, and then it's over there, and then you use Code Interactive node, and then it started to basically replicate all of this. This directly happens within your scene. Okay, so you need to set up the API key within Omniverse Kit extension, and you can follow this documentation link, and then that's where you can actually start to, like you said, use the NIM and then interact with the thing. So with that said, I promise we'll go back to our favorite monsters. Let me stop sharing. Sorry.
Okay, there you go. I got it.
Hope that answers your question.
That's fantastic. Yes, thank you so much. And again, the discussion doesn't have to stop during this live stream. Everyone can interact with us on the Discord server or in the official support forums. We'll post a link for both in the chat. Okay, here we go. Here's this one's from Zia about Kubernetes. I'm sure we have some of you are going to help with Kubernetes, but why is Kubernetes layer significant?
It's because eventually, once you serve a massive amount of the user traffic, we need to make sure all the names, and sometimes it's just not one name, right? There's many components that scale across and up consistently and robustly. So we want to make sure this is, cloud native and cloud first, which aligns with our positioning in building products, and hope to make it eventually easier to use, and also for the admins to easier to monitor all the, production deployment environment as well.
Okay, that's fantastic. I think I know the answer to this one, but I'm going to put it on the screen anyway. Are you guys trying to do this yourself or giving the tools to others to build enterprise-level applications?
Absolutely the latter. So
Yes.
our goal is to enable all the developers to build any applications. You know your application best, you know your user best, but we would like to, enabling that process to make that technology integration and the addition of the value-add technology as easy as possible. So we want to put these amazing tools in the hands of developer and make that easy for all of you.
Of course, it's a great. I'm so glad you asked that question, and that's the reason for some of the links you've posted previously, including the guide. So we'll post those in the description. Okay, here we go. This is from Arch AI 3D. Can we use USD Search on a local server? And the answer is yes. Okay, let's go to the next one. This is speed questions and answers. Is CFD rendering with OpenUSD is possible? Sorry, I'm reading that wrong. If CFD rendering with OpenUSD is possible, is it also possible to simulate drones and Isaac Sim and Isaac Ross?
Edmar, sorry,
yes,
man. The previous question.
Is that wrong?
Well, I guess some context. You're running USD Search locally, but it's pulling from
outside Europe.
Yeah, from a cloud source. So I'm not sure what he meant.
Okay,
is it running locally or in the cloud? It's running locally, but it's pulling assets from the cloud.
Elsewhere, yeah.
So if can you pull assets from a local server? Possibly, I don't know.
Yep, you absolutely can. We actually have early access today, and then soon we're gonna go roll everything to general access, general availability. Is you can actually have USD Search deployed in your local environment or cloud, and then that can index your local server. We do have some constraints on what database you use, either Nucleus S3 or S3 compatible. We have a proxy layer that's with S3 compatible. So these list of servers are possible to be indexed through with USD Search.
Awesome.
Okay, great. Awesome. We'll circle back to this one. Who can take this one? Isaac Sim Ross.
Yeah, CFD rendering, we're doing a whole bunch of it now. Not sure how much of it is public, and maybe I shouldn't have just said that, but no, we've demonstrated a whole bunch of CFD workflows.
I just erased everybody's memory of that.
All right, thank you. Using Flow and the index render.
Okay, cool. Thank you for that. And again, feel free to follow up with any questions on the Discord server, and we can try to help more detail. This is from Omniverse Ambassador Pekka Varis, who Dave acknowledged earlier. Thank you for watching, Pekka. Can we validate OmniGraph? I'm not sure.
Yeah, you need to double check. So if that, there's a good need there, we can double check with our team.
Okay, cool. Here we go. This is from Elijah. A major problem with such enterprise level tools is privacy. How does NVIDIA deal with such privacy issues? We take privacy very seriously, obviously, but I don't know about this specific.
Yeah, so there's, for example, I think when it comes to privacy, what's most important is user data, right? So we don't log any of the user data. So we basically, if you think about it, it is again, it's developer who will actually in your application level, you'll interface with your user. So you'll be responsible for interacting, implementing that layer of privacy. We do not, in our stack, there's no way for us to log or track any user data. And then on the entire NVIDIA AI enterprise software stack, we do a lot of the security patches and security screening to make sure that, the common vulnerability exploitation is being, we have a strong product security team is being actually all tested, right? So on the level of NIM, we make sure a lot of the security vulnerability tests are being mapped into our product, but our product by itself do not track any user data, user privacy. So hopefully that helps.
Yes, I think it does very much. So thanks for a great question, Elijah. Temporal Lab, how many refinement layers do you see this workflow evolving into? Okay, bye, Beth Ann. Thank you so much, Beth Ann.
I have to drop as well for 12:30.
Okay, thanks, Alex.
Bye.
Thank you. Okay, we'll try to get a last couple of questions here. Let me see. How many refinement layers do you see this evolving into?
Is this referring to the overall workflow or a specific piece?
I think he posted it during your.
Gotcha. Refinement layers in terms of control, I think the answer is as many as you want. The way that it generates them is it'll iteratively denoise in latent space. So if you're referring to the number of steps that I'm using, I think, is about 30. But if you're just talking about iterating over images themselves, ideally with STG, just one. You do one, and then you don't even evaluate it. It's spit out, and you get the result that you want. I hope that kind of covers most of the bases there.
I think it does. Thank you for that. Let me see. Here we go. Possible forklift from outside by MQTT. Is that IoT reference?
Yeah, I don't know if it's possible that we can hook up. Ashley, do you know if we can hook up MQTT to Isaac and have it move things via sensor data? I hear a lot of talk about that.
There has been talk about it. I'm not sure of the answer though, so maybe we can bring that one into Discord and we can explore it further.
Okay.
Okay, that was great. So thank you so much for that question, Martin. Again, so the conversation does not stop with the ending of this live stream. We are happy to talk with everybody every day on our forums, which is the best place to go for official support. So if you want to report a bug, feature request, and we can track everything on the forums. Otherwise, our Discord server is a great place to chat and engage with other users using our tools and apps and sample apps. And you can we'll have lots of questions that are separated by topic. There's Amelia posting the link there. So feel free to continue the conversation there. I'm going to briefly mention, for anyone who jumped in late, obviously we covered NIM's live stream. You can watch it right away afterwards on YouTube channel. And I think we wanted to really talk about one more thing about some of the things which are coming up next. I think a lot of people were asking kind of what's coming up down the road. I will post some newly announced microservices that will be available soon. We have the USD Layout NIM, USD Smart Material NIM, FEDB Mesh Generation NIM, FEDB Physics Super Res NIM, FDB Nerf XL NIM. So lots of cool stuff coming down the pike that was recently announced. And as you can see, this is a constantly evolving and exciting area for developers. So we are super excited to see what everybody does with this great information that the team presented today. I can't thank Dave, Paul, Bethan, Alex, Ashley, thank you all for joining us. Is there anything you want to leave people with that we might have maybe needs another call out or anything we missed?
I want to call out again, there is a new DLI course for taking the NIM that you see in the API catalog and how to translate those properties into an extension in Omniverse. So it's a step-by-step, it's a free course. It's on the Deep Learning Institute under self-paced course, under graphics and simulation. It is wonderfully done by Arnav. Shout out Arnav. He's traveling Spain right now, and he left us a great course before he left.
That's great. Yeah, fantastic. Really, really big help. Speaking of which, we had a lot of help behind the scenes on this specific live stream. So many thanks to the people at NVIDIA who helped put this all together. And of course, Amelia, who's working in the background right now during the stream. Paul, Dave, anything else that that we left out, or you want to?
I'll say one quick thing. These technologies, especially kind of the generative diffusion models, it's moving so fast. If anyone has seen the new Flux models out there, they are kind of mind-blowing, and I'm only just wading into those. But if you think that the stuff is kind of not quite there, keep your ears open. It's getting there, and it's really exciting.
Yeah, and just to dovetail on that, this is a massive initiative inside NVIDIA, and it's super important to us to drive this. And really looking forward to hearing back from you and how, if you're using the guide and you're testing it out, how's it working for you? Where can we use improvement? And just keep your eyes peeled, because it's only gonna get more exciting from here.
That's true. And wise words have never been said in the history of people. Thank you, Mr. Tyner. And really exciting stuff coming up on the live streams, actually, concerning robotics. So we're going to have a series of live streams completely revolving around robotics. So everyone out there who's working on robotics or wants to work on robotics, excited about robotics, we're going to have a full kind of back-to-back live stream series on robotics. I just pasted the link to our ad event calendar where you can keep updated. We're going to flesh out some of those topics and add more details, but you can go ahead and add some of those to your calendar right now. And again, thank you, everybody. Thank you for the hundreds of people that are watching right now. Really happy to have everyone join us today. Great comments. The audience is really part of this live stream. So thank you so much for joining us and being part of the conversation. And I will tell you also that keep your requests coming in terms of topics or any kind of features, functionality. The team takes all that stuff we get from the community and enterprise companies and developers very, very much in consideration when we decide what's needed next. So thank you all for joining us today. Ashley, any final thoughts?
I'm gonna go get lunch.
Yeah. I heard my stomach. I was hoping
I just watched all these people walk up the stairs with like lunch. I'm like, wait.
All right, maybe I'll meet. Maybe we can grab lunch together downstairs. All right, thank you, Paul and Dave. We will eat lunch in your honor, and because you're in different time zones, so you probably already ate. All right, thanks everybody. We'll see you next time. Stay tuned for robotics coming up on live stream series very shortly. Thanks
everybody.
again.
Bye.
Bye-bye. Thanks all.